Welcome back. Let's finish the review material. Hopefully you got through the first part and everything's kind of right? I mean, even if you didn't remember the distance formula, the equation of a circle, at least that's information that's good to review because again, we are going to be using it. As I mentioned when we talked about functions, evaluating functions, looking at even and odd, we're going to do all of that with our trig functions as well as one-to-one and inverse functions. So we need to kind of review, if you remember how you knew a function was one-to-one. So it says a function is one-to-one if any two different inputs in the domain, inputs x's, so any two different x values correspond to two different outputs in the range. So you put in two different x's, you get two different y's. That's all that really means. And that's what it's saying here. A function is not one-to-one if your different inputs correspond to the same output. So in other words, let's say two students in class have the same social security number. Well, that can't happen, right? So that wouldn't be a one-to-one function. And that's what this is saying here. So for every x, you only get one particular y. All right, this one's not one-to-one because you see two different x's goes to the same y. This is actually not even a function because one x is going into two different y's. The easiest way to tell if a function's one-to-one is the horizontal line test. So we take and we draw a horizontal line, and if we touch in two different places, then we can tell this is not a one-to-one function. So do you remember how you found one-to-one functions? Most students kind of remember this. It's where you change the x and y and then you solve for y. That's all this is saying here. So they left it as f of x, which is a little confusing, but they're saying that you interchange where you see y, you turn it to x. Where you see f of x, okay, that becomes f of y in this case. But once again, our y value, we're interchanging these. Then we solve for the other variable, the y, and that gives us the inverse. How we can check is by taking the inverse of the function, and we should get our variable back, or the function of the inverse, and we should get our variable back. So let's go through a quick example. Find the inverse of this function. So if you remember, we change where you see f of x, I just change it to y to make it easier to look at. And then you change your y to x and your x to y. All right, so don't forget that. You interchange your x and y. And now I'm going to take this and solve it for y. So I'm going to chunk the 3 to the other side, subtract 3 on both sides, and then I'm going to divide by 2, or bring the 1/2 out front. And this gives me my inverse function. So 1/2 x minus 3 is the inverse of 2x plus 3. If I graph these, it's easy to see. If I take and graph the original function, that's the blue here, and then the pink function, if we draw the line y equals x and it cuts right through it, in other words, it gives it that mirror image, then that proves also that they are inverses of each other. How you algebraically prove it was with the formula that I showed. So what we do is we plug in our original function into the inverse. So this was our inverse. Where you see an x, notice I plugged in 2x plus 3. And once I plug that in, 3 minus 3 is 0. 1/2 times 2, the 2's cancel, and I just get x. I have to do it the other way as well. So in other words, I plug the inverse into the original function. The original function was 2x plus 3. So where you see x, you plug in the inverse. You can already see that the 2's cancel, and I end up with x minus 3 plus 3. The 3's cancel, and I end up with x. So therefore, these are inverses of each other. So this is how, if I told you to algebraically check that they are inverses of each other, this is how you would check it. It's a nice little summary One thing to remember is the domain of a function is the same as the range of the inverse. This number 2 is really nice because if you know the domain of one function and the range of that function, you just flip them to become the inverse function. And number 1 here says if a function's 1-to-1, it does have an inverse. Number 3 is what we did the example. We verified that they were inverses of each other, and the graphs are symmetric with respect to the line y equals x. And to find the range of a 1-to-1 function, find the domain of the inverse. This kind of goes back to number 2. I did this section all by itself. This is very important. There will be an entire section of trig functions, but inverse trig functions. So be sure you kind of go back over this and you remember how to find inverses. You remember how the domain and ranges are opposites. So in other words, the domain of the functions, the range of the inverse, the range of the functions, the domain of the inverse. This is very, very important. So be sure you understand this. If you have any questions, you know where to find me.